Okay, so this is not C10, this is D10. There's another mistake here. It says predict the hybridization of central molecules. There's no such thing as a central molecule. I mean central atoms. Okay, central atoms. Okay. So we're going to go into a little bit more depth in terms of molecular shape. Okay. This objective is actually very simple to understand in some ways, but sounds complicated. The way the book explained it sounds really complicated. There's a whole lot of backstory to what hybridization is, but actually determining the hybridization of something is actually quite easy. Before we do that, what does hybrid mean? What does hybrid mean? What does hybrid mean? When we talk about a hybrid car, hybrid animal, what does it mean, Megan? Combination of two different things. So a hybrid car has what? Battery powered and gasoline powered. A hybrid car is part electric with a battery and part gasoline powered. What's a hybrid animal?
Part one animal, part
A pig and a goat.
I don't know. That's the first thing
I don't think I've ever done that. A platypus isn't hybrid. That's its own species.
like a mutt.
Not a mutt, I think, because those are all dogs.
Like a mule is a mule.
Mule is a hybrid animal.
Oh.
Yeah, it counts. A mule is a horse and a donkey. What's another anyone ever heard of any other hybrid animals?
No, you know.
A liger,
Isn't there
What?
like
A liger.
and, like something else? A zebra and like a.
a zorse.
That's not what I was thinking of.
Okay,
before.
there's a zorse.
So where'd they come to the name mule for God's sake?
You can't just toss two
We
animals.
didn't. We had a sword.
No, but these are look. There's a wolfen.
Yeah, he's done it.
A zebroid. That's what I think of. Zebroid.
Yeah, a zebroid is the real. It shouldn't be called a zorse. For some reason, it's called a zebroid.
It's so okay.
A donkey.
What's a camel?
Cama is a camel and a llama.
That thing looks messed up. Why is it beefalo? Why does it stink?
Yeah, I don't know what a beefalo
Wait,
is.
keep scrolling, keep going. Like, if you keep scrolling,
Beefalo.
A beefalo is a buffalo and a bison.
Wait, can you
Why can't they give them normal names like
Yeah,
mule?
he's done. Yeah,
This is all they got.
Can we look up more if we get to
No, because when I googled it, they showed all these fake ones. Like they showed all these
Yeah, but
photos.
these are fake ones too.
These aren't fake. A dolphin is real. It's a whale and a dolphin. No, I've never seen a
Do you
dolphin.
know someone who's seen a dolphin?
But a dolphin
What
is
about a
real.
beefalo? Have you ever seen a beefalo?
What's a wallaby?
Bro, it's like Wyoming, like, I don't know what it is.
Have you heard of growler bears? Grizzly bear and polar bear?
No, it does not.
Growler bears are real.
Polar bears? I'm aware polar bears are real, but what?
No, growler bear. No. The polar bears. The polar bears are like, you know how the ice is melting, so the polar bears are coming south because there's no more ice up there. And the grizzly bears, because it's getting warm, are moving north, and they're meeting in the middle. And they're making roller bears or grizzly or grizzlies. I don't know what a beefalo is.
You tell me they swim? Like they swim from right there? How do you really gotta swim?
Yeah, it's cattle and bison.
Can you look up the wolfen?
The wolfen is real.
It's the first
No, a wolfen is a whale and a dolphin.
Look at the teeth.
That is terrifying. That is
Is the
so
wolfen
scary.
still alive?
It's one of the world's rarest hybrid animals.
Yeah, because it's only
What do you say?
Oh, a zedong.
Yeah, it's like your screenshot.
A zebra and a donkey. A zebra and a donkey.
This is zedong.
Wait, a donkey and a zebra?
A jaglion.
I
A
thought
jaglion.
false killer whale. Wait, what is a false killer
I
whale?
don't
Doesn't
know.
have, I bet you it doesn't have
All
oil.
right, we're gonna stop.
I bet you it
No,
doesn't
no,
have
no, I
oil.
think we should keep going.
Okay, that's enough. So that's a little biology review, or maybe you never learned it, but anyway.
No, a mule. I learned what it was.
Okay, you-
last year.
All right, so you guys get what hybrid means. Okay, hybrid means two different things that are joined together. What we're going to talk about today is very exciting. A hybrid orbital. Okay, so a hybrid orbital is when an s orbital, and a p orbital. What shape is an s orbital? No, not dumbbell.
Then it's like this.
Sphere and p orbital,
Dumbbell.
dumbbell, and they come together to make a new orbital.
Let me guess. It's gonna be on our midterm.
And the s orbital and the p orbital come together to make an orbital called sp. Isn't that exciting? Okay.
SP.
Not as exciting as animals.
Well,
All right. So, the way books, not just your book, but any book explains hybridization of orbitals is always extra confusing. So I wrote this in a way that I think is a little bit more clear. So I'm just going to read this out loud. So an unbonded atom's valence electrons are located in sphere-shaped s orbitals and dumbbell-shaped p orbitals. So those 1, 2, 3, 4, 5, 6, or 7, or 8 valence electrons are always part of s or p orbitals. Okay, s's are sphere-shaped, p's are dumbbell-shaped. Okay, the orbital is the region of probable location. It's the region where you're likely to find those electrons. However, when an atom forms a covalent bond with another atom, sphere and dumbbell-shaped orbitals don't work because the electrons need to be located in the region between the two bonding atoms. So when the electrons are in a sphere or a dumbbell, they're not in the right place for bonding. They need to be between the two atoms. Therefore, when an atom bonds, its orbitals undergo a process called hybridization, in which the s and p orbitals mix to form new hybrid orbitals with new shapes that are ideal for bonding. In a hybrid orbital, the region where electrons are located is in between the bonding atoms, rather than in sphere or dumbbell-shaped orbitals, okay? So the s orbitals and the p orbitals, when a bond forms, they come together to make new orbitals that are in the exact right spot for bonding, okay? So if you look at this carbon dioxide, circle this area. That's an area where electrons need to be in order to bond. That's an area where electrons need to be, okay? So those are called areas of electron density. That's where the electrons are going to be in this molecule. They're not going to be in a sphere-shaped region. They're not going to be in a dumbbell-shaped region. They're going to be here and here, okay? And that's what the orbital looks like, okay? That's a region where you're finding bonding electrons, and that's a region where you're finding electrons, okay? Of course, electrons can be found outside of that region, but this is the region of probable location. So the word for this shape is not S, it's not P, it's called SP. Isn't that exciting? Okay. Let's back up for a second. I forgot to fill this in. How many areas of electron density are around the central atom? 2. So when you need 2 areas of density, it's going to form an sp orbital. Okay. 2 areas of electron density forms this shape orbital. It's called sp. All right, now look at the CH2O. The C is the central atom. There's electrons here, here, and here. Okay. So this is going to be a trigonal planar molecule. 3 areas of electron density. It doesn't matter whether that area is a double bond or a single bond or a triple bond. That counts as one area, one area, one area. So your orbitals are going to look like this. This is the spot where electrons need to be for bonding. Okay. The name of this type is sp2 with the 2 up high. sp2. We don't say sp squared. We say sp2. What's the name of that brewery in Aston?
2SP.
2SP, right. I always call it SP2 because of this. All right, so then we have something like this, areas of electron density. Circle all 4 areas of electron density. This has 4 areas of electron density for bonding, okay? So if 2 areas is SP, 3 areas is SP2, 4 areas is going to be SP3, okay? We're not going to go beyond 4 areas of electron density. There's rare cases where you have more than 4 areas of electron density. You'll learn that if you take AP chemistry. All right, this one, a lone pair counts as an area of electron density. That affects the geometry. That's an area, area. 4 areas. This is again SP3. Okay, and then same thing with this. The lone pairs count as areas of electron density, as well as the bonding pairs. 4 areas of electron density. Once again, it's going to be sp3. So for hybridization, it doesn't matter whether it's a lone pair or a bonding pair. It counts as an area of electron density, and it affects the shape in a very similar way. We know the bond angles for these are slightly different, depending on how many lone pairs there are. But overall, the general shape of those bonding orbitals is pretty similar. Okay? So that's hybridization, okay? just knowing that and seeing that and saying, oh, that central atom, that's sp3 hybridized. That central atom, that's sp2 hybridized, takes you so far. It's a very simple thing to understand that takes you very far in chemistry, because you hear that term thrown out all the time by college professors, and it's a pretty easy thing to understand. Just look at the areas of electron density. You know that that's going to be sp hybridized, whereas something like this is sp2 hybridized, and something like this is sp3 hybridized. Okay? So with that in mind, what we're going to do on the back is we're going to pull together a lot of our past objectives. Okay? So we're going to draw the Lewis dot structure. We're going to figure out the shape and the angle, and then we're going to figure out the hybridization of the central atom. Okay? So flip over to the back. Except I forgot to make you write the hybridization. So for each of these, you're going to draw the picture, then you're going to tell me the shape, the angle, and the hybridization. Write that down. So you're going to tell me whether the central atom is sp, sp2, or sp3 hybridized. Add hybridization to each of these. Okay, so I think these are all going to be covalent. Okay, I think the easiest way to draw these will be to use method 2, where you just add up all the electrons on the side. Okay, so draw your skeleton structure, and then add up the electrons on the side. Okay, so you can look back at D6 if you don't remember how to draw the dot structures. Selenium has 6 valence electrons, fluorine has 7, the other fluorine has 7 for a total of 20. Okay, so follow the steps in D6 to place the electrons. For the shape and the angle, look back at D9, and for the hybridization, look at what we just did, D10. Okay. So just work your way down. Go down 1, 2, 3, and then over here 4, 5, 6. Is your hand okay? Okay. So be sure you also do the hybridization for the central atom. So look at how many areas of electron density are around the central atom and say whether it's sp, sp2, or sp3 hybridized. You can look back at this will help you figure it out. So how many satellite atoms are around the central atom and how many upstairs? Did you take those off? This story now has 2, 4, 6, 8, 10, 12. All of these are being shared. Not so much. Which one? Oh, okay. So you don't need to do lines and dots. That is just your, yeah, just erase the line. Okay, got it. So these are sharing. Instead of having 8, yeah, you could give them back to the phone and keep it as a Number 1 is not linear. Okay, number 1 is not linear. That's your 10%. I'll show you how. Yeah, that's right. Now they all have the right amount. The way that I would do it is like you have 20, right? Make it a single box. Because you know, and then fill up the outer box. And then fill the central bottom. And then you can see 8. Number 1 is not linear. Are you trying to decode it?
Yes, right, so you had the 3.
Yeah.
3 brackets. How many, remember that.
Right, so I think you're trying to do it this way. Is it coming out? It's not, there's you can do it this way, where we have it, and follow this stuff. Perfect. Number 1 is not linear. No, it's great. Did you get the triple bonds here? Yeah. Oh, I thought it's 4. Yeah, you're I think it's look back at you and I and figure out whether number 5. That's the first one. What do we fill next? The outer or the inner? You have more. That's great. Perfect.
I would do like, number three. No, it's like,
Yep.
Alright. Oh, I put it there wrong. I went 1, 4, 3, 5.
See how the SI still doesn't have heat? So you're gonna have to make some double bonds, so erase those and move them to the middle, and erase those and move them to the middle. And so the sulfur still has heat, and now the silicon has heat also. Don't forget brackets for number 6, because it has a charge. Awesome. Good. Don't forget your brackets for number 6. Since it has a charge, don't forget brackets. Good morning, there. No, I'm saying the 20, right, you drew more than
So go to the account.
Yeah, I think you drew extra. Right, look at what they are. Or otherwise, it's a lot of clear for that one. Are you doing the section? No, don't do that. That's only if you think like 6 hours. So what's the first step? Yeah, you should look at that. No, you don't do this. That's not the one. You just think, oh, dot, 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 dot. The one that has the not the one that no, don't get so by doing that, they'll still count for oxygen. Not going to feel like it doesn't matter. If it doesn't work out like that, good. Oh, you forgot the charge. Remember, -3 means what?
Oh, okay.
It's gain 3 more electrons. Don't forget brackets for number 6. All of them are red. I don't know.
Oh, I put the packet together.
All right,
And then I had just paper.
there's 2 areas of electron density.
Is there, okay, I didn't know.
Yeah, I can.
Oh, no, this is, no, on the central atom.
There's
Oh,
just-
don't worry about that, that's not on the central atom. Only look at what's on the central atom.
I don't know those.
This one, you've got to like, okay, you've got to look at that nitrogen. How many areas of electron density are on that nitrogen?
I'll fix it just for you guys.
So there's like each number before the
It's
one of the molecules.
A different, each arrow is pointing to a different central atom. So I want you to tell me the hybridization of the atom.
Mister.
Which one? Put the bracket on the other side too. Like the whole thing has to be in bracket. For number 5, you don't have to tell me the shape or the angle, because it's a shape and angle we didn't learn, okay? But for number 5, you can still figure out the hybridization. All right, so take a couple more minutes and then we'll go over these. For number 7, tell me the hybridization of the central atom only. Tell me the hybridization of the central atom. If the central atom's not clear, tell me the hybridization of what the arrow is pointing to, okay? So focus on what the arrow is pointing to. Okay, so let's go over number 2, okay? If you're having trouble drawing these dot structures correctly, you need to watch D6 Part 2, okay? We did D6 Part 2 on Zoom. You might not have been paying attention, or you might have been absent that day. Rewatch D6 Part 2 if you're not sure how on earth I'm coming up with this, okay? You make your single bonds first, fill the outer atoms, okay? I'm not concerned with which of these were originally sulfurs and which ones were silicons. I don't care about that with method 2. I'm just putting them where I need them. I used up all 16. The silicon still isn't full, okay? We've got to move that in between. We got to move that in between. Now the silicon is full and the sulfurs are full, okay? There's no lone pairs on the central atom. There's just one satellite atom here, one satellite atom here. It's going to be linear. And the angle of a line is 180 degrees, okay? I'm going to jump to number 6. I'm going to post the answer key for 3, 4, and 5, okay? And oh, the hybridization here, sorry. Hybridization is just SP. There's 2 areas of electron density. For this one, there was lone pair, bond to an atom, bond to an atom. So this one is bent, 104.5. And the hybridization here is sp3. Okay, hybridization here is sp3. Whereas the hybridization here is just sp. If you jump down to number 6, P is the central atom. Remember, you got to add in 3 more because it gains 3 more electrons for a total of 32. Make your single bonds first, and then fill the outer atoms. Okay, and you'll see that it's exactly 32 to fill up all the oxygens. And don't forget your brackets in your charge.
During the Sunday, January 9th emergency school board of directors meeting, revisions to the health and safety plan for the Pendelco School District were passed. These include a requirement.
Wait, don't pack up yet.
For students and visitors to be masked in Pendelco School District buildings until further notice. Sun Valley students will be required to be masked beginning tomorrow, Tuesday, January 11th, 2022. Further details regarding the revisions to the health and safety plan will be communicated by the district today, January 10th. Please look for this communication. Thank you.
All right, and then for these ones, I want you to tell me the hybridization of the central atom. So let's say we have, the central atom here is N. 1, 2, 3 areas of electron density, that's sp2, okay? For the ones where the central atom is unclear, I drew an arrow, okay? This one's probably the trickiest. Picture 3 hydrogens coming off the carbon, okay? So the carbon has single bond hydrogen, single bond hydrogen, single bond hydrogen, single bond to the nitrogen. So that one would be sp3. But look carefully at each of these other atoms and tell me the hybridization of those other atoms. So for these, you write down the hybridization of the central atom, but if there's no clear central atom, do the hybridization of what I'm pointing to with the arrow, either sp, sp2, or sp3, okay? Is hybridization really that hard?
No.
It's kind of like easy to figure out, and it'll get you very far in college. All right, so I'll post an answer key for this that you can check. Okay?